started. Proflex is a new family of foot systems that we're introducing this year. Very exciting step, and we'll kick it off with some background as to how these were created. Basically, R&D has gone through a process of looking at what's been out in the literature in terms of ways that existing energy storing and returning feet can be improved upon, and also try to compare making something more functionally equivalent to what the anatomical and physical human body is actually doing in terms of foot and ankle performance. They found that traditional prosthetic feet show a relatively limited range of ankle motion, low ankle power generation, which results in increased sound side impact. That energy storing and returning feet are relatively standard for K3 to K4 level amputees, and they generally increase range of motion, ankle power, and sound side protection. Those things are relevant and potentially help to reduce comorbidities like osteoarthritis. Energy storing and returning feet have shown numerous benefits, but they still show quite a gap in terms of between what they do in physiological performance. So looking at range of motion, ankle power, and effect on the sound limb have been comparative sort of indicators in terms of performance for energy storing and returning feet. So looking at opportunities to improve, basically they focused on increasing range of motion to reduce shortcomings on ramp descent. We can also say ramp ascent and stairs as well is something that they focused on with this foot, but also developing increased push-off or power that would assist in terms of improving energy cost of walking and reducing impact to the sound side. So again, they're trying to improve upon with this system what pre-exists out there in terms of products, and how can we get closer to performance of the anatomical foot and ankle by using carbon fiber foot design. So what they've done with Proflex is they've delivered a system that has a series of functional and mobility benefits explicitly, and the combined effect of those benefits creates a medical benefit as well in terms of reducing impact and excessive varus moment on the sound side. So they've increased ankle range of motion by 82.2%. Now all these numbers on the screen are relative to our own Veriflex foot, which has been considered kind of an industry standard foot that's been copied to various degrees around the world. So they've increased range of motion with the Proflex to 82.2% compared to Veriflex, increased the ankle power by nearly twice that to 93.3% increase over Veriflex, and at the same time created a more physiological plantar pressure movement over the sole of the foot as you roll over. So what that means is that the rollover pattern with Proflex is more similar to the sound foot. We hit at the center of the heel, and we tend to be guided and roll over towards the great toe. The combination, again, of these aforementioned features is what is effectively reducing impact on the sound limb, and that reduction in impact is also translating to a reduction in varus moment on the sound side, which I'll discuss later relates to reducing potential degeneration of the knee joint with transtibial amputees and reduction of incidence of osteoarthritis. So how are we actually doing this? Proflex is taking 3 carbon fiber blades and basically tying them together through a series of pivot joints. So you can consider this in a simple explanation as a polycentric ankle geometry, which is a pretty interesting and innovative approach to a foot ankle system. That anterior axis is the central pivot axis where most of the action of the foot revolves around that point highlighted in yellow, which is really mimicking the ankle rocker or the talocrural joint. The other rotary points that you see posteriorly, you can think of, I think the easiest way to think of them as anchoring points that are basically manipulating what's happening with that middle central spring. which is going to make more sense in a few moments when I go through some animations on how this mechanically works. The blades basically then interact to control stiffness and rate of plantar flexion and dorsiflexion. And it's basically that manipulation of stiffness which is giving us a highly flexible foot throughout the range of motion in stance, but particularly in the mid-stance range. And we're getting a massive amount of range of motion, so 27 degrees range of motion in total. But what we're also getting, which is unique in a foot like this, I think, when you get great range of motion, we're also getting higher stiffness in terminal stance, which is going to assist in limiting dorsiflexion to a certain extent and assisting propulsion. That's where we get this 2 times the ankle power of Veriflex happening in that terminal stance to pre-swing transition. Okay. So during loading response, what happens is that the active heel is compressing, the upper blade is compressing. But we also then get a posterior rotation around that central axis, again mimicking that tailocrural joint, where you can think of those 2 posterior anchor points pressing that middle blade down, so putting some pre-compression on that mid-lever. And that mid-lever is going to load and deflect downward, storing energy during loading response, and giving us 10 degrees of real plantar flexion. In mid-stance, what's interesting is that you're getting rotation again anteriorly, or starting anteriorly, around that physiological center of rotation, and you're maintaining a full-length toe lever for maximum mechanical advantage. You can imagine that in a Veriflex or any other conventional carbon fiber foot, as you roll over from mid-stance into terminal stance, you're going to start to lose a bit of toe lever as you move across the foot. And what this is maintaining is really keeping the foot on the floor for a longer period of time, the heel on the floor for a longer period of time, and we're maintaining that full-length toe lever as we move from mid-stance to terminal stance. Okay. In terminal stance, we get the sole blade compressing, which is storing energy. The upper blade also starts to compress, which stores energy, and that basically, up to this point, is behaving like a normal energy-storing and returning foot. But then we get this anterior rotation around that central pivot axis, which, between those anchoring points posteriorly, lifts and pulls that middle blade up against the proximal blade. So we get this extreme compression that's happening with those 2 carbon fiber blades. And we also get quite a lot of dorsiflexion, around 17 degrees of dorsiflexion that's happening at this moment as well. The back link pulls that mid lever up, the blades are pushed together rather aggressively, and we get that increased range of motion of 17 degrees. So again, the foot's going to stay on the ground longer, we're going to get more support in terminal stance, and we're starting to preload those blades, storing up a lot of energy for push-off. So in push-off, we're basically, the mid-lever's creating that active plantar flexion moment in late stance, and that main pivot's going to undergo a backward plantar flexion torque, and we're going to get this big kick that happens at the end of stance, which is generating 2.9 watts per kilogram. That's 93% more than a Veriflex, and just FYI, it's only 12% less than a Biome foot, which is using an externally powered actuator to generate a powered push-off. So I'm going to attempt to go through, to run a video here, just so you can see what's happening on level ground and other alternative surfaces. Okay. And I'll run this twice, just in case you got lags on your end watching the video. Okay, but what you can see is that posterior rotation in early stance, the compression of those blades from mid-stance to terminal stance, and then the unloading and release of the energy at the end of the step. You can get the same advantages or similar advantages as you would with hydraulic ankles or microprocessor-controlled ankles that you may have used when you're walking on alternative surfaces. So we find it very easy to move into a dorsiflex position on stair and ramp ascent, making it much easier to basically roll over the front of the foot, transfer body weight forward, and power up stairs and ramps. You're getting that immediate adaptation to the surface as you would with some of those other systems like hydraulic ankles and microprocessor-controlled ankles. And that's going to make it much easier for people to go up and down these alternative surfaces. Again, same being true for ramp ascent. Immediate adaptation, allowing body weight to be transferred forward across the foot. This is also going to help in reducing adverse socket pressures and joint issues in terms of hyperextension moment on the knee and so forth when we're moving across these alternative surfaces. We can take a look at ramp descent as well. Again, that immediate compliance, and we can stay on the foot for a longer period of time by having all that dorsiflexion in the foot and that resistance that's built up in very terminal stance with the compression of the blades. Let that run just once more. Again, if those videos are slow on your end, we'll have those available for you next week so you can view them separately and in the presentation as well. Just to give you some numbers, these are the numbers that we found through some testing that was done in development, a significant increase in ankle motion with 11 users using Proflex versus Veriflex. So the PF from this study is representing prototype foot, which is actually Proflex. The CF is conventional foot, which was Veriflex, and the numbers in parentheses was the standard deviation. The asterisk is indicating a significant increase for the prototype foot or Proflex, and where you see the hash symbol on these numbers is indicating a significant reduction in that value for Proflex or the prototype foot. So you can see how that ankle range of motion moves up significantly on level ground, ramp descent, and ramp ascent compared to the conventional foot. And in terms of developing more physiological ankle power, what they did in the design with this was basically they manipulated where the stiffness buildup is happening in a Proflex compared to a conventional foot. It's giving you this relatively low stiffness and flexibility in the mid-range, which is reducing moment and pressure on the residual limb. It just makes it very easy to transfer weight forward and stay on the foot longer. What we're doing with Proflex is creating higher stiffness in late stance. That's what you can see by the blue curve versus the red. So that stiffness buildup is happening much later in stance, and that's also what's building up greater ankle power in late stance. So we're getting high energy return along with progressive stiffening, which is similar to what's seen in the anatomical ankle. It's basically what's happening with the action of the triceps suri in late stance by limiting dorsiflexion and assisting with propulsive force. That terminal stance is basically where you start to get 3 times the action, 3 times the force in the muscle that's built up in that portion of the gait cycle. So that's what we're trying to mimic with this foot. And that's what we see in the numbers. So in terms of peak ankle moment and stance, and peak ankle power generated in stance, if you can particularly pay attention to these numbers here, for the Proflex versus the conventional foot, again, you see nearly twice the power being generated in late stance there compared to the Veriflex. And those numbers actually increase when you look at ramp, descent, and ascent. Then when we get to a significant reduction in peak impact on the sound side, again, this is a result of a combination of these elements that we've mentioned before, the increase in range of motion and the increase in power. We're getting a reduced impact on the sound limb itself. So we can see that in terms of sound side impact. So how does that relate to advantages at the end of the day for the amputee? Is that with transtib amputees, we know that the sound side knee joint of amputees is 17 times more likely than in age-matched non-amputees, and knee pain is twice as common. So by reducing sound side loading and impact, we're also reducing external coronal varus moment that's applied to the knee joint. And these are two of the principal mechanical causes for knee osteoarthritis in people with limb loss. So that's significant, and this is a good medical justification for you guys to utilize a system like this with your clients, reducing that peak impact by 11% and knee varus moment by 15%. Okay, so what we've done in addition with Proflex is we've modified the sole blade on the foot, and that's offering a longer effective foot length for push-off and control. The blade itself was modified. You can see below the central images here is looking at a talix blade versus a Veriflex. And they've made this effectively 12 millimeters longer than the talix sole blade and 30 millimeters effectively longer than the Veriflex to basically guide rollover onto the great toe and give us better support in the terminal stance to pre-swing transition. And the sole blade itself is also wider to offer better stability and stance. So by modifying that sole blade, what they found with looking at center of pressure measurements is that the rollover pattern, or the center of pressure movement, is much more mimicking the anatomical foot, the sound side, and the Proflex than what we've ever seen with Veriflex. You can see that the pattern basically moves from hitting the center of the heel, moving laterally, and then transferring across the great toe, similar to what we see on the sound limb, versus the Veriflex, which tends to run through the center of the foot itself. And you also see the high pressure areas basically eliminated from what we see on the Veriflex and getting much closer, reducing those red areas, getting much closer to what we see represented on the sound side. In terms of user profile, I'm going to try to give you an overview of who would be a good candidate for a system like this without being too specific. What we're finding is it's a relatively wide range of users. Probably the main contraindication is anybody who's wants to use a foot for high impact use. It's certainly not a high impact device. It's for low to moderate impact only, but for a variety of amputation levels from transtibial, knee disarticulation, transfemoral, and hip disartic. From K levels, K2 to K3, and primarily for activities of daily living and recreational use, like, for example, hiking, using a foot for uneven ground, ramp surfaces, and stairs. The weight limit's up to 125 kgs. Yeah, obviously this is a foot that's going to be great for ADLs, but if someone's wanting to use the foot for recreational sport or sport-specific activity, I wouldn't recommend it for that. You'd want to look at the Proflex XC, which we're talking about in a few moments, which is the upgrade of the Veriflex XC. With the Proflex family of feet, there's also a new foot shell that we've incorporated. This is using a new EVA foot cover design. Some of the advantages of this foot shell design is really quite a nice upgrade and a long-needed upgrade that we've needed with the FlexFoot range. It's waterproof. Fits in the shoes a bit better. It has more anatomical features on the foot, lighter weight, has a curved opening which makes it a little easier to finish, a full-length toe which utilizes a sandal toe fitting on all the feet. It also has a higher coefficient of friction on the foot shell, so it makes it easier to walk on slippery surfaces barefoot. You get a lot better grip on those types of surfaces than you would have with our other foot shells. It's washable. You can paint the nails on the foot shell, and it comes with a new black Spectra sock. which has been received by most people very positively. I will say with Proflex that because we're using the coupling of these springs with the different rotation points, you're very much relying on appropriate category selection, so that's quite important to pick your category appropriately. There is a category selection chart that's specific to Proflex, so that's going to be important for you to reference that chart specifically. Again, up to 125 kgs and for low to moderate impact only. I would recommend with Proflex, probably if anything with category selection, that you err to picking a higher category versus lower. I'd recommend probably for most of you that you focus on the moderate impact selection category on the chart. If anything, people using Proflex have found it softer than too soft versus too stiff. So you'd want to err to going up on the category versus down. Proflex is also Unity compatible, so if you want to fit vacuum with it, you can do that. It is retrofittable as well, so the pumps you can buy with the foot, or you can retrofit them with a one-screw attachment onto the foot. It doesn't increase the build height, and it keeps the system incredibly lightweight for the person. In terms of fitting procedure, you're going to follow the bench alignment procedures that we've always done with FlexFoot by bisecting the socket at the MPT level and running that through the posterior middle 1/3 mark on the foot. So there's nothing different that you need to learn in terms of setup of the foot. What's probably more important is that you realize that in terms of dynamic alignment, you basically can only focus on using dorsiflexion and plantar flexion of the foot, and changes in AP positioning of the socket versus the foot in terms of adjustments. You're not using any heel wedges with this particular foot. It's an exception to the rule, and it's simply the wedges don't work with this particular design and can vastly degrade and from function and durability on the system. So you don't want to use any heel wedges with it. If anything, we've found that some candidates on the foot like to have a little bit more plantar flexion than others. So if there's one adjustment, I would probably encourage you to think about making it's a little bit of added plantar flexion for some users with this foot. Now let's spend a little bit of time talking about Proflex LP. The LP version of Proflex is basically an upgrade and has been directly compared to in development to our LP Veriflex. So it's offering greater ankle range of motion, so playing along that same theme of opening up the ankle motion range and improving physiological gait by incorporating that sole blade that we're using in the standard Proflex design. And we've also seen an increase in overall function and satisfaction with users using this compared to their LP Veriflex and even Veriflex foot. The Proflex LP, it's recommended for clients up to 166 kg, so you can take it up to a higher weight level. Obviously for longer residual limbs where clearance is an issue, and you can take it to moderate and high impact levels with this one. It's also Unity compatible through a retrofittable Unity pump. What's interesting about the Proflex LP is they did some rather very clever design implementations with this, which are simple but very, very clever and innovative. Particularly in the middle blade of the design, they reversed the taper. So what does that do? If you've paid attention to FlexFoot designs, typically the carbon fiber is thicker posteriorly than as you move anteriorly on the foot. What they've done with this reverse taper is they've actually created more flexibility then in that middle blade by making the taper thicker on the anterior than the posterior. And then what they've done to basically build up resistance to dorsiflexion or a progressive stiffening in terminal stance, they've added that top blade, which is basically a rocker plate that comes into contact with the middle blade and creates more of an increased stiffness as you move towards terminal stance. So it's really great. You get the flexibility that you want in the middle range, which is similar like the standard Proflex model, but you get that increase in resistance as you move into terminal stance, so you can stay on the foot longer and get the support you need. So it's quite a clever way that they put that together in engineering. I'll just run a short video for you, just to show Proflex LP versus Veriflex LP coming up the ramp. You can see a greater range of dorsiflexion happening in terminal stance, and the foot coming off the floor a bit later in terminal stance. So again, just highlighting that increase in range of ankle motion. I think it's particularly easy to observe when you're looking at ramp walking. You see a bit more of the action happening than in level ground walking. What we'll do is put there's a series of these videos that show ramp ascent, descent, and level ground walking, and we'll put those up on the website for you next week. Okay. So what you see next here, I'm running, there's a little bit of a lag here in the slide. I'm just waiting for the next slide to come up for you guys. Okay, it's popped up now. It's showing the toe keel stiffness characteristics of the Proflex LP versus the Proflex. And what's interesting, again, is that you get that, you're getting that increased range of motion, but you're getting that buildup of resistance in terminal stance happening later. There's a lower resistance to initial dorsiflexion, meaning less moment needed for the residual limb to load the foot, and a higher displacement for Proflex LP, indicating more ankle range of motion with the same load. So you see those lines, the orange and the black, following one another in terms of deformation pattern, so versus load. So it's interestingly in a low profile design trying to mimic what we see in Proflex in the standard version. In terms of user satisfaction, we also see improvements, especially compared to LP Veriflex, and approaching satisfaction levels of Veriflex, which is very, very interesting for a foot that's a very low profile build. It's unusual to see something that's matching satisfaction of a standard quality foot design like Veriflex. So I think particularly your LP Veriflex users will like using this foot in the future, and potentially some of your Veriflex users as well. The Proflex XC I'll spend a little bit less time on, simply because there's less changes, and it's something you're already familiar with from the Veriflex XC. So Veriflex XC has been upgraded to Proflex XC. Proflex XC, we've included this in the family to offer sort of a high impact option for people, and we're getting similar advantages again in terms of power and improvement and range of motion than what we see exhibited in the Proflex family. So we're getting increased ankle motion and reduced sound side loading compared to Veriflex, similar ankle motion and sound side loading when compared to Veriflex XC, a better rollover when compared to Veriflex XC. That's a result of the sole plate that's been changed in this design. And it's easier to cosmetically finish than the Veriflex XC. Basically, they made the pyramid size a bit smaller on this one, so it should be a little bit easier for you to finish. And overall, the PEQ values also went up on this in terms of overall function and satisfaction when compared to Veriflex and Veriflex XC. So basically, with the Proflex XC, you're getting a better foot than what you got before with the Veriflex XC. The Proflex XC is going to be recommended for clients up to 166 kg that are engaging, again, in moderate to high impact activities on a regular basis, recreational sport, jogging, gym work, things like that. This would be the go-to foot. And it is Unity compatible with the retrofittable Unity pump. Okay. So I think at this point, we'll go ahead and move into the upgrade of the RHEO Knee 3 and the addition of the RHEO Knee XC, which is pretty exciting. There have been some significant upgrades to the RHEO Knee 3 as of 2016. It was originally introduced in 2014, and we've had a lot of good response from the knee since then. And the RHEO Knee XC really opens things up a bit further. The RHEO Knee 3 we've been recommending for clients that are that K2 to K3 level. The RHEO Knee XC is really filling that gap for the K3 to K4 level user that's looking for extra added benefits that we'll get into in a few moments for higher impact and higher activity. Both of these units are now in a weatherproof design. So by weatherproof, what we mean is that we can use these in a wet or humid environment, but we're not allowing for submersion at this point. Freshwater splashing against the unit from any direction is fine. So what we're excluding, again, is submersion, exposure to salt water, exposure to chlorine. More specifically, the weatherproof design is rated to IP34, meaning that specifically it protects from solid objects greater than 2.5 millimeters, and water splashing against the knee from any direction won't have any harmful effect. And just so you guys are aware, the ingress protection ratings only describe ingress protection for electronics. So these actually don't cover mechanical parts of a product. That's true for us, and it's true for all the other manufacturers as far as we're aware. This is really an electronic protections rating, what you're getting with this. Okay, but just to tell you specifically what engineering did with our designs in terms of the weatherproof protection elements, they coated the angle sensors and the spring. They waterproofed the vibration mechanism. They redesigned the electronics in a closed and sealed box. Silicone plugs around all the wires, water protection around the load cells, around the battery connector, and they fully enclosed the battery pack. So all the electronics and a few mechanical elements are well protected from the elements here. This is a short video showing you the testing apparatus that they use to verify and validate that functionally this is working. Okay, so hopefully you can see that on screen. Just run that for a few moments. Okay. So basically they spray the unit from all directions with fresh water and make sure that everything is still functioning appropriately. So it's an exciting step for us to get into the weatherproof range of systems with these electronic devices. We've also added for these systems, we've added the ability for you to program the units through the PC using the RHEO Logic software, which is still available through us via email. That's how we supply that particular software for the PC. That's in standard Bluetooth version, and you also now have Össur Logic, which is available through the App Store for iOS devices, which is a low-energy Bluetooth method of programming. The software is provided free. We don't charge you for any versions of the software. Again, now you have your choice whether you want to go, you're wireless either way, but you can go through your PC or go through the iOS devices. Again, Össur Logic you can get through the App Store. It does require iOS 8 devices or higher and a customer number to get full access to the CPO version. You can get that customer number from us. The RHEO Logic version is distributed online from us via email, and you download that onto your machine directly from your email. Both versions of the software include exactly the same functions. However, the Össur Logic version, this is just my personal recommendation, I like it better. It's formatted with instructions for each adjustment. So it tells you what the adjustment is and how to basically adjust the parameter, which is quite helpful, especially if you're not using this kind of software every day. I just find it very user-friendly. Personally, I also like the iOS tablet applications. It's just a little bit easier to use in terms of speed of connection with the knee, and it doesn't tend to disconnect as easily from the unit once you're connected up. So it's very user-friendly. I just listed there that the pairing codes are a little different. For the Össur Logic, the pairing code is the 6-digit serial number you enter from the knee, and for the RHEO Logic, it's only the last 4 digits of the serial number. You can use the Össur Logic app with, again, iOS devices 8 or later, and it's compatible with iPhone, iPad, and iPod devices. With the Expert app, you get basically everything you want to look at and everything you need to manipulate to get the knee working and read anything you need off of it. From calibration, static loading of the knee, the auto adjustment setup sequence, manual adjustments, any of the activity reports, status, step counts, activity, everything you get on this, this setup with the Expert app. With the user app, it's much more limited, but it does give the user some valuable information to reference in terms of battery status, charging status, step count, instructions for use, and different alarms and alerts that they can reference. So with respect to the RHEO KNEE XC, it's offering basically, it's an additional knee that is offering 3 additional critical functions for the active amputee. It's offering a stair ascent mode, a running mode, and automatic cycling recognition, which we'll get into in a few minutes here. So a much more fully functional unit for more demanding users. In terms of the stair ascent mode, we can go foot over foot up the steps with a bit of training. Okay, what it requires is greater than 25 degrees of knee flexion and loading in order to engage the mode. At which point the knee basically activates the swing extension stop at 25 degrees of flexion. So as you extend the hip and then basically initiate some hip extension and then rapid flexion, you move up the step foot over foot, and that extension stop basically prevents you from hitting the step that's next, and it helps you pre-position the foot for loading. You can go ahead and engage in different stair ascent strategies using the prosthetic side first or the sound side first. There's some training methodologies that we go through with the user to be able to train this. It does take a week or two to get proficient with this, and it takes a build-up of basically some rhythm and timing, good body posture, loading of the prosthesis, appropriate hip extension and flexion control, and most importantly, development of confidence. Kathy's been really good in working with us to develop some good training methodologies for people to learn how to go up the steps more easily. I'll just run a short video showing how this works for someone who's developed proficiency with it. Okay, so hopefully you're able to see this. This is someone who's had a bit of practice, and they are able to develop quite a good reciprocating gait going up the steps foot over foot. Again, when someone first starts, the motions are quite a bit more exaggerated, and then they tend to exaggerate a lot of the motions less in terms of triggering the mode and getting up the stairs efficiently. Obviously, in terms of stance control, stance is active when they load the prosthesis, and they have active stance extension happening, but they're using their hip musculature to basically ascend from step to step. So it does require sufficient hip extensor power to be able to do this. Okay. It's interesting that R&D looked at a stair assessment index when they did development with this system, and this was carried out on folks, which I'll get into a little bit later, that were using different microprocessor knees prior to the assessment, including some Geniums and X3 devices. And what they found was, with the RHEO KNEE XC, that the RHEO KNEE XC improved in terms of this overall index after 3 weeks of using it compared to the baseline prosthesis that was used. It was interesting that they noted that Genium users that did not use the stair ascent feature on a daily basis were able to use the stair ascent feature with the RHEO KNEE XC. They found it was simply easier to trigger the stair mode. And we believe that basically if you're finding it easier to trigger the stair mode, you're going to be quicker and more apt to learn how to use this type of feature on a day-by-day basis. It's just, if it's quicker and easier to learn, you're going to use it. In terms of automatic cycling recognition, basically this is not to say that if with previous RHEO devices you couldn't ride a bike. This just makes it a lot easier to ride a bike. Makes it more intuitive. Basically what you do is you step onto the bicycle, you have 2 rotations of the pedal, and it acknowledges that you're on the bike and riding, and it basically eliminates any kind of resistance in the knee entirely. So you have this free swinging sort of feeling as you're on the bike, and it gives you this long beep confirmation when you're in the cycling mode. When you go to exit the bicycle, the knee's just extended anything less than 15 degrees, and you exit the mode. You get a beep confirmation that you're out of the cycling mode. So makes it very easy to get on and off the bicycle, frees up all that resistance within the knee, and just allows you to do this without any mode switching whatsoever. The running mode is similar. It doesn't require any mode switching. You just intuitively run. You just go for it. It's designed for intermittent running, typical of what you would do in everyday life when you're going for a jog or doing gym work. It is only recommended for users that are less than 110 kgs, so there is a weight limitation there. And basically what happens is as the user takes off into a running gait, the knee acknowledges that when the stance time is less than 0.3 seconds, it engages this particular mode, which basically opens up the swing range for heel rise and provides adequate swing extension dampening. Also during running, the stair ascent step over step mode is blocked for safety. We do recommend for users that are running with the RHEO Knee XC that we recommend using the Reflex Shock or Rotate or the Proflex XC in terms of foot selection. But really nice added advantage again with these features is that you don't have to switch any modes. They're just intuitive, and the stair ascent mode just requires a bit of training up front to get into that. One of the things that's made running more possible and has allowed people to walk faster with less effort is the fact that they've made some significant enhancements to the extension assist mechanism in RHEO to allow for a faster extension rate, to promote better heel rise and toe clearance. And basically they've found with some in-house studies that this has lowered overall energy consumption and exertion. And again, this has also assisted us in being able to create or allow for running in the RHEO Knee XC. Basically what they did was they changed the spring constant of the material that they were using with the spring, and they changed the winding so that you don't get any kind of disturbance of heel rise and swing, and you get more aggressive extension in sort of the mid-range of swing where you want it. They did an internal study on 13 unilateral TF users. This is the same study that I alluded to with the Stair index that I referred to earlier. They had a series of previous RHEO knee users and 4 hydraulic MPK users, including a C-Leg 4, 2 Geniums, and an X3. They focused on the K3, K4 population, and they compared basically the results of using the existing knee to the RHEO Knee XC after 3 weeks of use. And they found an 18% increase in the overall distance walked in the 6-minute walk test, a 30% reduction in exertion according to the Borg scale, and a 9% average reduction in L test times. In terms of the 6-minute walk test, I found particularly interesting because when they compared the results, people were able to walk farther than they had in the 6-minute walk test with their existing prosthesis. And what's interesting is when they went into the literature and looked at what existing stats are on active duty soldiers, the results were comparable to performance of active duty service members in the U.S. Army. So it was interesting that people were able to step up to a new level and within that particular high performance range. I found was particularly interesting with this. With the Borg scale, on top of that, they were walking farther in the 6-minute walk test, but they were also walking farther and expending less energy or less effort, which is fantastic. So this just highlights the efficiency of RHEO, which has kind of always been there in the design from the beginning. It's always been a very, very efficient walking mechanism. And I think with all the enhancements we've had to it in recent years, that's just improved beyond a reasonable doubt. And then when they looked at the L test, there was also a performance improvement here in terms of being able to do the test faster. So they were able to reduce the times on the L test as well. And these were all statistically significant. The PEQs also increased, so the overall satisfaction and the feel of an improvement of quality of life improved with the RHEO Knee XC compared to previous versions of RHEO and the other MPK hydraulic devices that were trialed in this study. I'd also like to mention that the track record in terms of RHEO performance, in terms of reliability, has been really, really good since 2014. We've had a very, very high reliability record with only a 2% return rate for repairs to units sold globally since January 2014. So that's really significant. I think if you start utilizing these devices, hopefully that you're spending less time dealing with repairs, returns, and complaints over time. There's a 5-year warranty included with these, no scheduled service required in the first 3 years, and a mandatory service required at 40 months. Now I'm just going to go over what was changed in 2014 with the design transformation we really saw with RHEO Knee 3, and this is more a review for those of you that have already been exposed to RHEO Knee 3, but these are all still the same functional elements that are included in the new devices. We're still using magnetorheologic actuator technology, so if you're not familiar with that technology, we're using a series of rotary blades that are housed in a zero pressure actuator, so it has very, very low resistance and swing that we can move to very high resistance that's proportional to changes in gait and loading. I'm just going to run this little video in the bottom corner. Sort of shows the fast response time of MR fluid to a magnetic field. Basically, we can move things, again, from that very low resistance braking to very high resistance instantaneously with a change in current. This allows for very natural swing initiation because we're using basically a zero drag actuator. We're also using a very intelligent programming elements in terms of using some artificial intelligence that's able to learn as the user walks. This has different layers to it, but we still use an initial automatic programming or setup mode that's now only 30 steps to set up. So once you've done your bench alignment and static alignment, you basically have your client walk 10 steps at a slow speed, 10 at a self-selected, and 10 at a fast speed. And RHEO is going to set up all the baseline swing and stance parameters for the user. All you're left with doing then is basically just fine-tuning certain elements of it. And over the years, that programming, automatic programming, has gotten better and better and better. It's really quite easy to set these up and very fast. We also have long-term continuous monitoring and adaptation that happens with respect to changes in activity level and changes in the weight of the shank in terms of changing shoes and things like that. The knee will respond automatically and change resistance levels instantaneously and adapt over time. So you don't have to change or manipulate the swing control settings, if at all, with the system because it's doing a lot of it autonomously. The idea is basically to enhance and maintain walking comfort and efficiency over the long term. We've increased progressively with different iterations of RHEO the torque output in the unit. It's a stronger actuator now, especially in the new versions that have just been released than what we've ever had. There's more resistance over a wider range of knee motion. This has given people a lot more confidence in terms of stability coming down stairs and ramps and traversing uneven terrain. Engineering's basically been able to do this by increasing the surface area of the blade, adding blades, and increasing overall voltage in the battery. We're able to put more current through the unit, and by increasing that magnetic field, we're able, and with the combination of these other factors, we can increase overall peak torque, which has been very helpful for folks in terms of stance support. We've also added a kinematic sensor, which I think most of the market here is more familiar with this term gyroscope, for enhancing stability and security in stance to swing transitions. It's also improving stability during quiet standing. Basically what the kinematic sensor does is it's detecting angular velocity changes. It identifies angular orientation versus time from mid-stance to terminal stance, and identifies obviously forward motion versus walking backwards. This makes more predictable and safer transitions from stance to swing. It also identifies quiet standing, and when someone is in quiet standing, loading the prosthesis, it increases stance resistance to maximum for better stability and reduce stress to the sound limb. This has vastly improved users' confidence. Some simple sort of performance examples with this is that, if someone wants to stand for a long period of time, standing still with the knee flexed or extended, they're going to get really good solid stance stability. And it's going to prevent inadvertent release from stance while walking backward or pulling objects as you're walking backward. We've also enhanced the angle sensors, processors, and software inside the units for better reliability, and also, changing things from analog current control to digital current control has smoothed out the sort of feel of the knee compared to previous versions. So the knee does feel smoother in terms of swing and stance control. The battery, as I mentioned before, has been made larger, which has helped us with running current through the knee to get better stance support, but it's also helped us with longer life of the battery on one charge. So we can get up to 72 hours of continuous use on one charge. Okay, which will allow for more extended activity and less charging frequency. Okay. It takes about 3 to 4 hours to fully charge the unit. And with the versions that were introduced in 2014, our weight limits also went up to 136 kilograms. With respect to the running mode on the RHEO KNEE XC, that weight limit goes to 110 kgs. But for all other activities, it's 136 kg. The manual extension lock was added in 2014, which has been really useful for a lot of people in terms of extended standing, but also for traversing extreme terrain, very, very steep slopes, for example, or using it in a power off mode. When RHEO goes to a powered down mode, it does go to a free swinging knee, but now the user can choose to lock that up or walk with it in a free swinging manner, whichever way is more comfortable depending on their level of voluntary control. So that's really fantastic. A lot of folks have also, the active users have come back to us and told us that they're using this for activities like yoga and for doing gym work in terms of work with various weightlifting machines, but also for planks and push-ups and activities like that. It's been particularly useful. If you're not aware, we do have a bionic protector, which is a relatively rigid foam fairing that fits around the knee. That's really good in terms of additional protection from the elements and protection from impacts. There's a threaded top adapter for long residual limbs if you need a threaded top, and we also have angular linear shift adapters if you need flexion offsets as well. Finally, I've got a reference for you guys just in terms of build heights and weights for the unit and knee flexion range to 120 degrees. Within the software, if you're not familiar with RHEO, we still have an alignment support tool, which is basically helping you to give indication for loading on the knee during your static alignment process. We're not giving you strict guidelines in terms of where load lines need to be transmitted through the unit, but this is giving you an idea of relative anterior to posterior load across the knee and foot. In terms of the auto adjustment process, I mentioned that before. It's been made more simplified to a 30-step sequence for setting it up. So as soon as you do your bench and static alignment, you just have your user walk 30 steps at varying speeds, slow, self-selected, and fast. And then when you're done, you go ahead and deactivate that auto adjustment mechanism, and you can do fine-tuning to manual adjustments. All the manual adjustments there are the ones you've been used to before. For swing and stance, there is a new setting that's been added. For some of you, it will be attractive if you've been looking for it before. RHEO historically, and it still does, sets up the stance release point from transition from stance to swing. It does that automatically for you when you first do the auto adjustment setup. RHEO still does that, but now you have the ability to manipulate that release point if you want to. You can make that release from stance to swing happen earlier or later if you want. Depending on the user's level of voluntary control or foot that you've selected, you can go ahead and tune that. So I think that'll be attractive for particular individuals you work with. Also, we have the activity reports that you can download from either the iOS device or your PC. They give you step count, and it also gives you an overview of the different walking speeds that the person has been using. This will be interesting for you to track over time and may be useful for you for your justifications with payers, and to see how people are actually progressing with the use of the device. At the same time, this also gives you a printout of all the existing settings that you've put into the knee. So if you send something back for a service and you have a loaner unit, you can install those same values back in that when you have a service done on the unit. And that's about all we have for you today. We'll stick around for a few moments if you guys have any questions. And we thank you very much for attending. We know how busy everybody is these days, so we really appreciate you taking the time out to spend with us, and we hope it was of good value.